Hi everyone, in this video I'm going to be showing you how you can combine multiple plots in a single page in R programming language. So normally when we want to plot or perform a data visualization, we can only place a graph on a single plot. So what if we actually want to combine, or let's say join these particular plots together on a single page? So instead of having two different plots or two different images having two different plots, we can just have a single image having two plots. So that's what we are going to be learning throughout this particular video. So first of all, we need to load the tidyverse package. So we're going to load the tidyverse package. Then also we load the ggpubr package. So please, if you don't have it, you can use the function install.packages to actually install them. So this is in case where you don't have these particular packages installed in your R programming language. So if you don't have it, you can just run this particular line of code and it's going to install everything for you. Then after installing it, then you're now going to load these particular packages. So we're going to be needing the tidyverse, especially the ggplot2 and dplyr in tidyverse, for us to be able to demonstrate how you can actually combine this particular plot into a single page. So we're going to be using the diamonds dataset as a case study. So we're going to just be doing some basic plots with the diamonds dataset. So the first plot we are going to be plotting is diamonds frequency. So we're going to be plotting diamonds frequency by cut. So we're going to pass the diamonds dataset. We're going to pass it to the ggplot function aesthetics and give the cut as the x-axis. You can see x is equals to cut and fill is equals to cut. Then we're now going to pass this to the geombar function. We're also going to pass this to the ylab. So just we want to give our y-axis a label. So I'm going to say y is for number of diamonds. Then we pass it to xlab, which is diamond cut. So then I'm also going to give the title gg title, which is frequency of diamonds by cut. Then I'm now going to pass this to the coord flip function. So we want to flip this particular graph. So instead of making it a vertical bar plot, I'm going to make it a horizontal bar plot. So let's just run this. So after running this, now we already have our plot. So we are done with one plot, which is the frequency of diamond cut by frequency by diamond cut. So let me actually call this, let me name this particular plot. So let me just call it diamond frequency cut. So I'm saving this particular graph as a variable now. So if I call diamonds frequency cut, I can now view this particular bar plot. So as you are seeing it here. So now the next thing now we're going to do now, we are going to visualize the distribution of diamond price. So distribution of diamond price. So distribution of diamond price, I'm going to save it in a variable called price distribution. So I'm going to pass the diamonds data set. So I'm going to pass it to the ggplot. And since we are plotting a density plot, so I'm going to give in only one particular variable, which is price. Then we are going to pass this to geom density. Pass it to geom density. I can now say plus gg title. So we're going to assign our title, which is distribution of diamond price. So we already have our second visualization, which is distribution of diamond price. So if I call it now price distribution, so let's run this, then run the next one. So you can see I already have my plot, which is distribution of diamond price. So now for the next third plot, we are going to be plotting 4 plots. So this is just to demonstrate, just to show our demonstration. I'm going to be plotting 4 plots. The next is going to be diamond price by color. So this one I'm going to be making a box plot. I'm going to store it in the variable diamond cut price. So diamond cut price. So we are going to be showing various diamonds, various diamonds color, the price of various diamonds color. So we're going to say diamonds pass diamonds. So I'm going to pass the diamonds data set to the ggplot as usual. function aesthetics. So give our color on our x-axis, our y-axis is going to carry price, then color is going to be equals to color. So I'm visualizing a box plot in this situation now. So I'm going to be using geom box plot, then I'm going to now assign my title, which is gg title, using the gg title function. So diamond price by color. So this is it. So when I run this now, and let me now call diamond cut price. So you can see I have a very beautiful box plot here. So that's for the third plot. So for the fourth plot is going to be diamond frequency by color. So diamond frequency by color. So you know the first plot we did diamond frequency by cut. Now it's going to be diamond frequency by color. I'm going to be calling it diamonds frequency color. So now I'm going to be assigning this to the diamonds dataset. I'm going to be creating a variable, and assign the diamond dataset to the ggplot. So to the ggplot function. Aesthetics, so color we're going to be on x-axis, and fill as usual. You know the bar plot only carries one axis or one variable, so I'm going to give the fill as color, then the geom bar. Then we can now pass this to the y lab, which is the number of diamonds. Then I pass this to the x lab. That's I want to get the label. I want to give the label to my x-axis, diamond color, then gg title. Gg title is going to be frequency of diamonds by color. This is the title of our plot. So then I will now add this to the cohort flip. So I'm going to be flipping this particular graph to get a horizontal bar plot. Then I'll now say diamonds frequency color. I'm going to call diamonds frequency color. Sorry, I've not run this. So now I have my plot. Good. So now we have 4 plots already. So we're going to be making do of these 4 plots. So now how do we now combine these plots together to form, like, let's say a single plot? It's very easy. So what I'm just going to do now, we're going to say gg arrange. That gg arrange belongs to this gg arrange function belongs to that pubr package we installed and loaded earlier on. So now I'm going to be giving diamonds. So I'm just going to be using, for example, now let me just use 3 plots. Frequency color. So please know that these are the plots we just created now. You can see why we store them in a variable. So price distribution and diamond cut price. So you can see now the gg arrange function is going to take the names of your plot first. So you're going to give your plots first. Whether you're giving 4 plots or 5 plots, you're going to list all of them first, separating them by a comma. Then the next you're going to be giving n column, which is the number of columns you want. So I want 2 columns now currently, and n row, which is the number of rows you want. I also want 2 rows. So I'm going to be having a grid of 2 columns and 2 rows. So when I run this now, so sorry, I made a mistake earlier on. This is supposed to be double R. So when I run this now, so you can see the plots now. I'm having frequency of diamond by color. This is a 2 by 2. This is a 2 by 2 grid. You can see 2 columns and 2 rows. You can see the frequency of diamond by color. You can see the distribution of diamond price. You can also see diamond price by color. So this is just very easy. You can lay as many graphs as you want using the gg arrange function. It's very easy. So what in this situation now, we are having 2 particular plots that are having the same legend. So now, for example, now let's just go to this. It is diamond frequency color. So you can see now I'm having diamond frequency of diamond by color. So let me just change this now to cut. So when I run this now and I run this, so I'm going to see frequency of diamonds now. This can now see I'm having the frequency of various diamonds color, but it is grouped by their cuts. So now I'm now going to be using this particular plot now. Frequency of diamond by color and frequency of diamond by cuts. So let's use this gg arrange. So remember, it's a double R. We're going to be saying diamonds frequency cuts, diamonds frequency color. So we're going to give in a common legend. That's why we need this common.legend argument, which is going to be equals to true. Then we're now going to say legend is equals to bottom. So the legend should be placed at the bottom. Then we now have number of column. So our number of columns is just 2. So which means we should be expecting 1 row but 2 columns. So when we now run this, so you can see now the frequency of diamonds by cut and the frequency of diamonds by color. You can now see that both of them are sharing the same legend. As you are seeing it, both of them are sharing a common legend. So this is how you can place common legend between 2 particular plots if you are combining them on a single page. So now you have already seen how you can combine multiple plots in a single page, or let's just say in a single grid. So you can just combine multiple plots you have already done, then you can just put all of them together in this particular single page. So now what if we have text, tables, and also plots? How do we now combine this together? So we can also use the ggarrange function, but the thing is that we have to convert the tables and the text to plots. So we cannot just use them directly. So this is what I'm going to be showing you now. So first of all, we need to let's create a table first. So I'm going to create average diamond price by cut. Average diamond price by cut. So I'm going to be saying, so average diamond price by cut is going to be diamond price, which we are going to be creating a variable called diamond price and pass it to diamonds. Then group by cut, then summarize. Price is equals to mean. So the mean of the diamond price, then diamond price. So you can see what we now have now. We have a table now showing us cuts of various diamonds and price. This is the various diamond cuts that we're having, and we also have the average price in each particular diamond cut. So we can't use this particular table like this. We need to convert it to a table. So let's say we need to convert it to a plot. So how do you now do that? This is where the gg text table functions come. We're going to say gg text table. You can see the function here, and we give the name of our table, which is diamond price. So you can see the name of our table. Then we say rows is equals to null. Then we can now give theme. So this theme is just like the color you want the table to be. So just something similar to Excel. You can see theme M green. So I'm just going to give it color green. So when I now call this now table, when I call table now, wow, what a nice looking table. So similar to some pivot tables in Excel. So just similar to what you have in an Excel worksheet or workbook. So now the next thing is going to be for the text. So I'm also going to create a text. So I'm going to say text is equals to paste. So I'm going to use the paste function to just join the text together. The diamonds data set is a sample data set that comes with, then let me put comma, the ggplot2 package. It is a great data set for demonstrating, then let's put our comma, demonstrating examples and also practice. So when I run this text now, so you can see my text already, but I can't use this directly with the ggarrange function. I first of all need to convert it to a plot. So this is where I'm now going to be using the text plot. I'm going to be creating a variable called text plot, just like I did for that of the table. And ggparagraph, we're going to say text is equals to text, comma, face. Put text, then when I say face is equals to italics. If I want it italicized, then I'm going to say size is equals to 15. So by giving the size equals to 15, then I say color is equals to black. So color is going to be equals to black. And I can now say text plots. So you can now see now I have the text as a plot. So now things are getting interesting now. So now let's now go to our ggarrange function. Let's go to the ggarrange function. So now I'm going to combine the text, the table, and just one of those plots we created earlier on. So I'm going to say ggarrange diamonds frequency cut. So this one I'm going to be using then text plots, then table, then n row which is equals to 3, then n column. So we are going to be expecting 3 rows and 2 columns. N columns is equals to 2, then height, okay, let's just leave it like that. We can leave it like that. N row is equals to 3. Okay, let me just make it n row is equals to 2, sorry, then n column is equals to 2, then height. So this is the height of the plots. I'm going to be saying 1, 0.5. So this is the height of the various plots, 0.3. So when I load this now, so I'm still forgetting my double R. I'm used to writing with single R. So you can now see the plots that I'm having, though it's looking choked up. When you expand it, I'm very sure it's going to look more nice. So this is just a sample of what I can do. So there are other tricks you can do to it to make it appear much more neat. So this is just how you can use this particular ggRange function to combine multiple plots into a single page. So you also have an alternative which is much more easier than the ggRange function. So another alternative I'm going to be talking about, which is very much easier than the ggRange or the ggpubr package, is the pathchwork library. It allows you to use mathematical operations to combine your plots. So first of all, let me show you a simple example now. We only have 2 mathematical operators which you can use in pathchwork, which is the plus sign and the division sign. So the plus sign is used for putting plots in different columns. It does in 2 different columns but the same row. While if you want to put a plot in the same column but different rows, you use the division sign. So first of all, now the text plot I created earlier on now, I want to put it in the same row but different column with the table. So I'm going to be saying plus table. So you can see what I'm having now. So they are both in the same row, but you can see they are in different columns. So what if now I want to have these 2 of them now in the same row, but I'll be having the diamond cut price. So the diamond cut price now, that is the box plot we created earlier on, is now going to be in another row. So what we just did now, we placed 2 plots in the same row. So I'm going to be placing now another plot which is diamond cut price. I'm going to be placing diamond cut price now in another row. So you can see what we're having now. So I can also make the diamond cut price to build another plot also on that same row. So I'm going to be saying diamond, let's just say frequency, color. So though the graph might look choked up, but this is just an example. So you can see what we're having now. You can see something like this now. So just know that the pathchwork is even much more easier than the ggRange, except that the disadvantage the pathchwork might be having is that you cannot actually give a common legend. In case you're having 2 plots having the same legend, you can't give a common legend to 2 of them. So this is one of the disadvantages of the pathchwork. So but it's based on your choice. The one that you see is much more easier for you to use, then you can use it. So you can just see that the plus sign places 2 plots on the same row, while the slash sign or the division sign places 2 plots on the same column. So these are just the 2 operators used in the pathchwork.